Good morning, everyone. Today we will start with section 4, color and polarization. First of all, we will talk about color. We know that every object has a color. So the color of the object depends on what? What do you think? It depends on two things. What are they? First of all, it depends on the light you shine on it, and secondly, it depends on the light it reflects. Okay, so because we know, girls, we get the reflected rays always when we see objects. We get the reflected rays that are coming from these objects toward our eyes. Okay, such as the examples we talked about before, like when you look into the mirror. When you look in the mirror, you see yourself. How? Because you are receiving the reflected rays coming from the mirror. The same thing happens with everything around you. When you look at everything, you are able to see this thing because the object is reflecting rays or light into your eyes. Okay, so the color of an object appears different depending on the lighting conditions. The color of object depends on which wavelength of light shine on the object and which wavelengths are reflected. Okay, remember that white light or visible light, it's combination of 6 primary colors: ROY, GBIV, or 7 elementary colors: red, orange, yellow, green, blue, indigo, and violet. These colors each have different wavelength. That's why I said before, it depends on which wavelength you shine on the object and which wavelength the object reflects, because each color, it has its own wavelength, okay, and its own frequency. For sure, we talked about this in section 1, which was the base of this chapter. Just as like different types of electromagnetic waves, you remember radio waves, they have different wavelength and frequency than microwaves, different than visible light, different than infrared. So invisible light, in this section also we have different colors, and each color, it has its own wavelength and its own frequency. So when light hits an object, some wavelengths, or you can say some colors, are absorbed and some wavelengths or some colors are reflected. Okay, let's see this example. We have a green leaf. The green leaf, we know that it's green. Okay, so why we see it green? Because it reflects simply the green light into our eyes. Okay, so when you shine on the green leaf white light, see here, you can see, girls, that here the white light is made of all the colors: red, orange, yellow, green, blue, violet. So the white light is you shine it here on the green leaf. So the green leaf absorbs all the colors except what? Green. It doesn't reflect it, instead it reflects it back to your eyes, so you see it green. Okay, here we have a very important question. If a red light shines on a green leaf, what color will the leaf appear to be? Imagine, girls, that the green leaf is in the room where there is only red light. There is no white light at all. Okay, let's say that there is no white light at all. There is only red light in the whole room. Will you be able to see the green leaf, do you think? No, we are not. Why? Because it appears black, nothing. Why? Because only red light, it's and the light that's going toward it, it's the incident ray. Okay, so only red light is going toward the leaf. Okay, you are shining only red light on it, and red doesn't contain green, only red. So green will not be reflected, the the leaf will absorb this red light and will reflect nothing. So nothing is reflected, it means that you are going to see a black object, nothing. Okay, so because the color of our object is green, okay, so if you shine on it red, this object will absorb the red and it has nothing to reflect, so it has no green to reflect, so we will not be able to see it, we will see it as black. So green objects, they only reflect green light. When white light shines on green objects, white light, we know it contains all colors, so no problem with it, for sure we will see the leaf green. But when red light only shines on the green objects, for sure red doesn't contain green, so therefore the light will be all absorbed, the red will be all absorbed, and the object appears black. Here we have many examples. You have a red book, for sure if you shine on it white, I will see it for sure red, because the red book will absorb all colors and reflect what the red color. Here we have a purple pen, so you shine on it white, I will be able to see it in its correct color, purple. So white hat, so also you shine on it white, so it will reflect. What means white? White, it means all the colors. So when you shine white on white object, so this object almost will reflect all of these colors. Okay, because red contain red, white contain red, orange, yellow, green, as we said, all the colors. So this white object will absorb them all back. That's why, girls, like in summer we usually wear what? White light, white objects, white shirt, white t-shirt. Why? White t-shirt, it's able to reflect almost like all the light incoming, so this will make you feel like cooler. Okay, but if you wear like black t-shirts, the black object, it means it has no color, it's black. Okay, so when you shine on it white light, it will absorb all the colors and reflect nothing. That's why when it reflects nothing, it means like you will feel hotter, right? Because the t-shirt you are wearing, it's absorbing more light, so you feel hotter. That's why like usually we wear black or dark colors in winter. Okay, if you look at colored object in colored light, we see something different. Let's see what we mean by this sentence. We have here a red t-shirt and blue pants or shorts here. So when you shine on it white light, it's okay, the shirt for sure will look red and the short will look blue, the correct colors. But if I shine on them only red light, see, what about the t-shirt? The t-shirt, its color is red, so it will not absorb the red, it will reflect it, because every object reflects its own color. Okay, our short was what? Blue. So when you shine on it red, the blue object will absorb red and nothing is reflected. So nothing is reflected, it means the shorts look black. Here the opposite, you are shining blue light on these two things, so the t-shirt will absorb the blue and reflects nothing, so the t-shirt looks black. But the short is taking blue and it will not absorb the blue, instead it will reflect it into your eyes, so the short look blue. Okay, so why objects have color? Visible light, as we know, so is combination of many colors, many wavelengths, which give it a white appearance. When light hits an object, certain wavelengths are reflected and others are absorbed. Reflected wavelengths or reflected colors are the ones we see and determine the color of an object. So that's why reflected light is the most important thing. It determines what you are able to see, what you will be able to see. Okay, here we have a tomato. The tomato under white light, we will see it normally red. Okay, so in the first picture the tomato absorbs blue and green, all the colors, and reflects only red. In the second picture, see here girls, we are shining only red. Okay, we are putting, for example, this tomato in a place where there is no white light at all. We put only red. Okay, so only red light, so the tomato will appear red for sure because it will reflect this red light back into our eyes. So in the second picture the red light is shown upon the tomato, so the tomato is still reflecting the red light and thus it still looks red. But look at the third picture. The third picture, only blue light is shown upon the tomato. So when you shine only blue light upon the tomato, so the tomato will absorb this blue light and will reflect nothing because no red light to be reflected. So we see it here like black because it's not reflecting red light into our eyes. So but in the third picture blue light is shown upon the tomato, and since the tomato absorbs the blue wavelength, the tomato appears to be black. Okay, so here if someone like ask herself, how can we get only red light? So to get only red light or only, for example, blue light, here we need filters. Okay, so filter, it's what? It's like just a transparent material that transmits light. If I want only red light, I use red filter, like red transparent material. You shine on it normally white light, and the light that passes through it is only red. Then you use the red in your experiments or in what you want to use it. Okay, here I have magenta filter, so I want the color magenta, so I shine on it white. Okay, so the light that will pass through it from it is only magenta. Okay, so in order to get here like only red light or blue light, we can use filters. This is everything for today. Tomorrow we will start with the part of additive primary color, so have a look at it. It's very important also. Thank you.